We're at the 2019 CROI in Seattle. We're here with Irini Sereti, who has already done her presentation at the CROI here at Plenary. And we appreciate her taking the time to describe her presentation to us. And we'll maybe have a few follow-up questions.
Sure. So in my presentation, what I try to do is explain why there is inflammation in the setting of infection of HIV infection, and specifically why there is residual inflammation despite suppressing the virus with antiretroviral therapy. So chronic inflammation is something that we see in people living with HIV, and that has been associated not only with mortality but with a lot of end organ diseases that include cardiovascular disease, lung disease, bone disease, neurocognitive disorders, frailty, and cancer. So we are trying to understand the roots of this problem and what is causing this residual inflammation, and come up with strategies to fight it. And so far there have been several studies trying to attack different aspects of this inflammatory state that we see in HIV with moderate success, some obviously better than others. And what I try to convene, the message that I try to convene is that we really need to look at what are the root causes of this inflammation, and then what can be done to avert it. And I think the data so far support that the earliest possible therapy may be the best approach to date, and also treating aggressively comorbidities. And by comorbidities, I mean simple things like high cholesterol or high blood pressure or smoking or obesity. And going after these factors may actually reduce significantly the burden of these diseases and this excess inflammation.
So the opportunistic infections or comorbidities are actually causing some of the inflammation?
So the opportunistic infections is something that happens in the beginning before antiretroviral therapy, and perhaps they do change. They cause some injury in the tissues, and they may have some more residual inflammation. But even in the absence of opportunistic infections at baseline, we still see this inflammation, which could be related to ongoing viral replication, either active...
In spite of active retroviral.
Correct. So there might be low degrees of viral replication, or the virus may just be sort of producing some of the proteins even though it cannot replicate, and this could be sensed by the immune system and causing this inflammation. It could be cytomegalovirus, which is another virus that tends to partner a lot with HIV and reactivate.
Even though it might not be in an active state, it would still?
Yes, but it can spontaneously reactivate from every now and then. So, for example, there has been a study trying to using an antiviral against CMV, cytomegalovirus, that showed some decrease in this immune activation. And then, finally, it could be things like the gut injury that we see in HIV, or the tissue fibrosis that we see, the fact that people do not really recover their CD4 counts at normal high levels. So all these factors contribute to this ongoing low degree inflammation.
Do you have any idea what percent of the people deal with this? And let me ask you a question before that, is that, so some inflammation is okay, but when it goes excessive or out of control, that's a real problem.
Correct. And I think the important aspect here is that acute inflammation is usually okay when you're trying to fight an infection or some tissue injury, but
not
the body has to heal. And so this ongoing chronic inflammation is what has been associated with a lot of diseases of aging, and it's something that goes way beyond HIV, so it's not something very unique to our field. And so it's something that we see that contributes in the general population also in cardiovascular disease and cancer and overall morbidity and mortality.
Yeah. So how do you, now I forgot to mention that you're with the NIAID, National Institutes of Allergy and Infectious Diseases, at the NIH, National Institutes of Health.
Correct.
Earlier, but that's that's where you're conducting this work, or in concert with others?
My laboratory and my clinical team are at the National Institute of Allergy and Infectious Diseases at NIH, but I also do have a lot of collaborators in other parts of the country and outside of the U.S.
Right, and so where do we go with this with this work? How do you, because it's really important to control this chronic inflammation.
Absolutely. So the study that has moved the farthest along is the study that is testing a statin, a drug that typically is used to decrease cholesterol. So the study is called Reprieve, and the statin that they're using in that study is pitavastatin. So that study has already enrolled 6,500 people, and that's a randomized controlled study where we're going to see whether people living with HIV taking this drug may have not only obviously lower inflammation, but if that leads to better outcomes, clinical outcomes. So we're going to see whether it can decrease the incidence of cardiovascular disease, but also cancer or any other end organ damage that we're seeing. So this is the most mature study, but I think until we have the results of that, I think the important message that needs to come across is that we really need to diagnose the infections as early as possible and start therapy at high CD4 counts, and also to try to be very aggressive with treating comorbidities. And finally, to go back to the bench and do more research and try to understand better the roots of this inflammation and how we can go after it in other possible ways.
Is there anything that you know of that's presented here at the CROI that's helped you in that direction, or have you had a chance to review everything?
So far, the studies that are being presented at this CROI have, for the most part, negative results or unexpected, unwanted results.
Okay.
So I mentioned some of these in my presentation, so I think we need to keep looking and waiting for the results of the big study trial.
The one thing you just mentioned is that some of them have negative results, or results that were unwanted or unexpected, and that's an important answer too.
Absolutely.
Yeah,
yes.
so you can move forward and say, now
Absolutely.
you might say, well, no, wait, maybe we should have done it this way or that, or this is why we got to this and we should have done this to avoid that. But at least you have an answer, and you
Absolutely.
have now, you know what determinants caused that answer.
Yes, I completely agree with you, and I think that definitely gives us a lot of important information and will help us understand better the pathways of inflammation and how complicated they are.
Yeah.
And
Because the body's redundant.
exactly, and to some
sometimes-
degree, that's exactly what's happening. If you don't go to the root of the problem and you go in between, you may have some
the body,
unexpected findings.
right,
the body will try to balance things
compensate
out.
and- yeah,
Absolutely.
yeah. So it's the body is really good, but sometimes when you're dealing with a virus like a retrovirus, it's that's actually attacking that function.
Right.
It now has become difficult to tease out how to deal with that in the mix, you know,
Absolutely,
and it's
yes.
very complicated. So
The immune system is very complicated,
Yes,
and
and-
we just need to figure out which way, in which pathway we need to intervene to
Exactly.
achieve the best
to
possible
the root.
results without risks.
get to the root cause.
Yes.
Well, it's very interesting, and you know, we tend to look at things in terms of basic science and how important that is. And I know that our audience sometimes will say, "Oh, basic science is too complicated," but you know, you've done a pretty good job of explaining it for the lay
Thank
ear, and I think it's important to do that because we need to know the work ahead that you have, the work you did, and of course, how we're going to get to the solving the problem. And you're on the way,
Exactly.
and you're on the way.
All right.
Thank you very much.
Thank
Irini.
you.
Thank
It's
you.
a pleasure. Thank you.